June 2005, and on a sunny Sunday afternoon, thousands of people gather on London's South Bank to take part in the annual Walk for Life, a charity event to raise money for HIV and AIDS. The walkers are sent on their way by celebrities Sir Ian McKellen and John Barrowman.
In the television industry, which I am involved in, we lost a vast amount of people in the very beginning, in the early 80s, when the disease first came into everybody's mindset. But and some celebrities are still, unfortunately, afraid of the stigma.
Amongst the crowd is 25-year-old Clint Walters. But he's not just here to chat at celebrities. Clint is a man on a mission.
Okay, I'm in the process of setting up the only weekend HIV testing clinic. The idea is to encourage more young people to deal with their own issues in making the decision to have the test, to receive the counselling, to have the support and to get results back in 1 hour.
Clint has marshalled a team of volunteers to raise over £6,000. But why is he so keen to set up his HIV testing clinic?
Well, when I was 17, I had a whole range of illnesses. The doctor said to me, can you come back into the hospital for more test results that have come back inconclusive? I immediately phoned my mum. My mum took me into the hospital, and it was then that they sat me down as I pulled up my sleeve and expecting to take more blood and said, you're HIV positive. My mum was right next to me and she just walked out of the room crying.
Aged only 17, Clint had contracted HIV, the virus that causes AIDS. It works by destroying the body's immune system, and there is currently no cure. Unluckily for Clint, he progressed from HIV infection to full-blown AIDS in just a few months.
I think at that point I just felt really lost. I was 17, I believed the doctors because they knew a lot more about HIV than I ever would. So when you're at that age, you kind of, your whole world's taken away from you.
Clint is just one of an estimated 50,000 people living with HIV in the UK. However, it's very easy for people with the virus to feel totally isolated.
I knew nobody with the virus. The only place for me to go to was to go to the States, because in my thinking it was more advanced, it was more ahead of its approach to treatments and testing. And that was really what opened up my eyes and changed my life and made me able to talk about it on TV today.
Clint's American experience inspired him to try to set up a testing service for young people in the UK. But he's very aware that information about the disease must be accessible to those young people. He arranges a meeting with HIV specialist Dr. Michael Brady.
How do you find the best way in explaining HIV, because it's such a complicated disease and it's a complicated virus? How do you find the best ways to convey that to young people?
I think it's important to keep it as simple as possible and use simple analogies. So if I draw you a picture, so what HIV does is latches onto the outside of these CD4 cells, fuses with the outside of the CD4 cell, and then basically deposits its genetic material inside our CD4 cells. So that's the first stage of infection.
That's when the cell and the virus will just lock together.
Yeah. So the virus, absolutely. It's like a lunar landing.
HIV targets the body's immune system, the very system that normally protects the body against infection. The HIV virus infects a specific type of white blood cell called a CD4 cell. It attaches itself to the cell, becoming part of it, and inserts its genetic material into the cell's own genetic material in the nucleus. In this way, it uses the infected cell to make more virus particles. As the mass of virus builds up, the CD4 cell membrane bursts, and virus particles swarm out, ready to invade other cells.
If you think of the immune system as being like an army, being there to fight infection, the CD4 cells are kind of like the generals, so they're there to kind of coordinate it. And without those, your immune system kind of falls apart, which is how it causes disease, because by destroying the CD4 cells, it weakens people's immune systems. So that's, without treatment, certainly CD4 counts drop, and that's when people get, or potentially get, a risk of getting HIV or AIDS-related diseases.
HIV belongs to a family of viruses called retroviruses, because of the way they carry their genetic material. Because of this, any drugs developed to combat the virus are known as antiretrovirals. Current antiretrovirals are aimed at stopping the virus from replicating in the cell. But even better would be to block the virus from infecting CD4 cells in the first place. And a new range of drugs that do just that is now being made available.
One of the major problems or the major challenges that we have about treating HIV is the development of drug resistance. The thing about HIV is that's very clever for it and very difficult for us is that every time it reproduces, every time it replicates, it often makes lots of mistakes in that process. It produces billions and billions of copies of itself every day. And a lot of those are abnormal, but because it does it so rapidly, sometimes by chance, it can turn into something that gives it an advantage. In other words, it can turn into a type of virus against which the drugs don't work.
Right. How do you actually keep the levels of medication within the body to fight the virus in the first place?
It's a really complex issue starting on HIV drugs. And because basically what we're saying to somebody when you start them on therapy is that you need to take these drugs probably at least twice a day, every day, for the rest of your life. And if you think about what happens when you take a drug, you get these big peak levels as the drug gets absorbed and it gets distributed around the body. And then as time goes by, those levels start to drop off, and that's as the body breaks it down and metabolizes it and excretes it out of the body. Now, if there's a certain level, imagine that's the level that you need to suppress the virus. When you're taking the tablets, you need to make sure that your drug level in your system is always higher than that. Because if you drop lower than that, in other words, if you've got less drug in the body than that, the virus is going to start to replicate. I mean, you take antiretrovirals, don't you? I mean, why do you think some people find it harder than others?
I mean, initially for me, when I first started taking treatments, I had every side effect. You know, I really had a severe reaction, skin rash all over my body, every known diarrhea, lost a lot of weight. I remember even, you know, just the inconvenience of my body adjusting to the drugs.
But you kept taking them though, despite all that. So you knew that you needed them. So was the main driver to keep taking them, the fact that you knew you needed them to stay well?
I think for me, you know, I'd experienced illness and been really sick. I had such viral load, you know, high virus in my body that's affected my nerve endings. You know, that kind of made me more aware.
The antiretroviral drugs saved Clint's life, and he's gone from dying of AIDS to living with HIV. However, Clint is one of the lucky ones. He lives in a country with free access to treatment for the disease. But antiretroviral drugs are expensive, and many countries cannot afford to provide treatment for life. Pharmaceutical companies say they need to sell the drugs at this price to pay for future research, and are reluctant to sell them for less or to allow others to produce them more cheaply. One answer could be a short burst of antiretroviral treatment soon after infection.
The biggest project we have here at the moment is called SPARTAC. And SPARTAC is a clinical trial short for short pulse antiretrovirals at conversion. So we're interested in looking at men and women who just recently acquired HIV infection, and to ask the question, if we give just a short burst of drug therapy or combination drugs at that time, is there a long-term benefit? Is there a benefit to them years later? So HIV in my lifetime has gone from a disease which was completely untreatable to being a disease which is now treatable, like diabetes.
Drug treatment will always be expensive. It is estimated that £1 of prevention is worth £9 of treatment, and the poorer areas of the world are crying out for a cheap, reliable method of prevention. Sub-Saharan Africa is worst hit, with just over 10% of the world's population containing 2/3 of all people living with HIV.
One area we've been looking at is to develop materials for women to use, chemicals that can be used in the vagina to prevent HIV transmission. And these are called microbicides. The reason we need something like this is, first, you don't have a vaccine, and secondly, that if you promote condoms for men, no matter how strongly you're promoting them, you're still only targeting half the population. So if you can get an intervention for women, you've got twice as much chance of interfering with transmission.
Microbicides work by killing the virus on contact. Microbicide gel can be inserted into the vagina before sexual intercourse and should prevent a live virus from being able to infect either the woman or the man.
When the results of the microbicide trial comes through in a couple of years, how accessible will it be to people, say, in Africa, or the cost implications?
I mean, when we started on the microbicide program, one of the first considerations we said was any chemicals we move forward with have got to be cheap. So I'm talking, $1 US cent a dose. Brilliant. And wherever you go in Africa, you can get a Coca-Cola and you can get a beer. So it can be done. The organisations exist. The question is how you access them.
The microbicide trial looks promising, but the long-term aim has to be to produce a vaccine that could protect the world and eradicate HIV. However, Producing a vaccine has proved extremely difficult, and pharmaceutical companies have often ignored this area of research in favour of producing drugs. One place where a vaccine is being investigated is the Chelsea and Westminster Hospital's St Stephen's Centre, where Clint meets Dr. Anton Pozniak.
Patients who have had lots of drugs and are drug resistant, then they've got very little chance of becoming well again. So one hope is that we could give them a vaccine. And what we would do is we take the HIV virus, we strip the coat off it, and we put a new coat on that we've modulated, and it's dead and it can't infect patients, and then we give a whole boost of it into the body. The body then thinks that that's HIV virus, produces antibodies, these chemicals, and it triggers off cells.
Vaccines make use of the body's own defence systems to kick-start an immune response. This way, you can become resistant to a disease without having to catch it first. Once they recognise a foreign invader, the body's immune cells react by first producing chemicals called antibodies, which stick to the intruder and label it. They also bring in other cells that now recognise the labelled virus as foreign and attack it. Crucially, the body's immune system also remembers the invader's identity, so it can fight it off if it comes into contact with it in the future.
So what's your biggest obstacle right now in vaccine development?
It's really trying to find a good vaccine, which means that the bit of the outer coat of the virus, if you could find a bit that doesn't change, as the virus mutates, that this doesn't change, so it's absolutely stable. It just stays the same all the time. What we'd really like to have is a good candidate vaccine, a vaccine where we think this is great, we can put this into patients, and that might treat their HIV, or we could give it to people and prevent their HIV. But the problem is we've got to check all of this out firstly in the laboratory.
Once they have a potential vaccine, it needs to be tested in the lab at the cellular level. White blood cells are separated from blood samples taken from healthy donors and mixed with the vaccine to see if it causes a reaction. What researchers are looking for is the production of antibodies by white cells and changes in other white cells that mean they can recognise HIV. There is then a whole series of other tests before the vaccine can be trialled in people.
Usually it's given to healthy volunteers and it's injected into their arm and make sure it doesn't cause a great big reaction. So there's all of that to be done. At the moment we've got some vaccines where we have changed the outer coat, but what we're doing with these is we're giving them to patients who already have got HIV to try and stimulate their immune systems so they can kill off the HIV they've already got in their body. So that's called a treatment vaccine rather than a preventative vaccine.
The big dilemma for the world's governments is where to put their money. Do they invest in treatment and forget difficult vaccine research? Or do they go all out for a vaccine and halt new drug research? Or are massive awareness campaigns the answer? With an estimated 40 million people infected worldwide, HIV is going to be difficult to conquer.
What I would say to kids who are watching at home is HIV can impact anybody. It doesn't matter your background, where you come from, black, straight, gay, white, who cares? HIV is a young people's disease, globally speaking. You know, over 50% are under the age of 25, so it's a young people's disease, and only young people in the future are going to be able to want to stop it.